my name is Ilya Khosravi Khorashad and I am a member of Lab Pattern Recognitions at Ferdows University of Mashhad, working under the guidance of Dr. Hadi Sadouqi. Today I want to discuss a critical and timely topic: bias in artificial intelligence. Artificial intelligence has become transformative force shaping everything from healthcare and finance to education and entertainment. But as we marvel at its capabilities, it is vital to acknowledge one of its significant challenges: bias. Understanding bias. Bias refers to unfair or one sided decision making stemming from partially. In humans, it is influenced by cognitive shortcuts and personal experiences, but in AI, bias emerges when algorithms reflect these inequalities from their training data or design. For example, here, consider gender bias in image recognition. Researchers shows that some AI systems associate images of cooking primarily with women perpetuations stereotypes. This highlights the dangers of training models on unrepresentative or skewed datasets. Now there is two questions. The first one is, why should we eliminate bias in AI? And the second one is, how to identify bias in AI. Let's dive into the first questions. The answer is, bias in AI systems arises from biases data, leading to skewed results. This is especially problematic in supervised learning, where highly quality unbiased data is essential. Biases AI can cause, first, the harmful consequences, and second, negative impacts. First, the harmful consequences is about misidentifications, examples, monitoring in images, gender discriminations, for example, credit rating apps. And the second one is about the negative impacts. The negative impacts are reduced trust, legal financial risks, and harmful for individuals and businesses. Let's dive into the second question: how to identify bias in AI. The answer is, bias detection is challenging, particularly in deep learning models, which often affects as a black box. That means providing results without revealing how they are derived. This lack of transparency makes biases hard to spot. We can change them and actually change these black box into the white box. This method is named is explainable AI, aims to increase transparency, turning the black box into a white box by providing clear, interpretable explanations of model decisions. For example, image classifications. In image classification, we have black box problem. For example, a neural network classifies medical images, examples, healthy versus pneumonia affected lungs, with high accuracy, but doesn't explain its decision process, reducing trust actually. But we can use white box solution with GradCam. You can see in this picture, GradCam is gradient weighted class activation mapping. Generates a heat map overlay showing the parts of an image the model focused on to make its decisions. For example, a heat map highlighting lungs regions with fluid build up can help doctor understanding why the model diagnose the pneumonia. It has benefits. The benefits of explainabilities is the first one is build trust. For example, the doctor can see that the AI focuses on medically relevant areas. The second one is enhances transparency. Users gains insight into the model's reasoning. The third one is improves adoptions. Increase, increase the interpretabilities leads to greater acceptance of AI tools. By eliminating the bias and ensuring the explainabilities, AI becomes more reliable, trustful, and effective in decision making. And now I want to show you the types of bias. The first one is sampling bias. That can you see occurs when one feature is overrepresented in data collections compared to others. The second one is measure bias. Occurs when data is not measured or recorded correctly. For example, you can see in this picture. The third one is exclusion bias. Similar to sampling bias, exclusion bias arises from data that's it's inappropriately removed from the data source. And these are the types of bias, and I here write the solution to eliminate biases. Now I want to show you the example in productions. Here is an example. It's an example of AI bias. The problem arises because we have more normal images than pneumonia images in the dataset. The question is, how can we use AI without having the bias? But here we have bias, and then I will show you these bugs with the bias. This is our code. We have 32 batch size. Image heights of our images are 100 pixels. Image widths are 143 pixels. And these are the training datasets. And these are our convolutional neural network layers. You can see here. And actually we use the ReLU and sigmoid function for activation functions. Then we train the model with 3 epochs, and then we can see the actually accuracy of these datasets. When the datasets consist of 35% abnormal images and 65% normal images, the model achieves an accuracy of 76%. However, when the distribution is 55% normal images and 45 abnormal images, the accuracy increases the 93% for accuracy. This is a high accuracy for detection pneumonia. So the first one shows that the bias can increase the accuracy, and when we eliminate the bias, we can increase the accuracy of our models. Thank you for your attentions, and goodbye.